Hello everyone, welcome to my channel. I'm Dr. Vivian. So in this video, we will continue our topics in probability. So in our last videos, we already talked about what is a sample space, what is event, and what is experiments in probabilities. So you can have the link here for these videos. And now in these lectures, we will talk about what is some rules about size and Venn diagram. So because sample space and event is a very important terminology in probabilities, as both of these two terminology is a site. So this is very important for us to understand some computation of size and some rules about these computations. And also the Venn diagram is also another very important tool here. So in last video we already said generally the event is denoted by some capital letters. For size is similar. We can denote this by capital A, B, C. So here I choose the size is denoted by capital E. And if we have several ones, we differentiate them by E1, E2, and E3. Then the first computation for the event is about intersection. So what's the meaning for intersection? So if you already learned something about the programming, so intersection is very similar to AND. So it means this is the elements in all the sides. So the intersection of the event contains the elements of generally it's like the outcomes in all sides. So this is intersection. And we can denote this if we have two sides E1, so we will denote this by this symbol. So we call this is E1 intersection E2. And of course, if we have more event as the size, we can have E1 intersection E2 intersection E3 and even more size. Then about the Venn diagram, this is a very useful tool to show the meaning of some computation of the size. So here we denote the S as the whole size. Here we denote this by S, and then we denoted each side as a circle. So now I have first one circle, so this is our E1, and then I have another circle. So this is our E2. Then the intersection of E1 and E2 is the area covered by both of these two circles. So here I show this in a yellow color. So this one is the meaning for our E1 intersection E2. Okay, so now this is about intersection. And then there is also another important computation of size. The name of it is union. So union, this is very similar to the OR in our programming. So it means this contains the outcomes. So contains the elements or elements in either size or the one of the size, one of all sides. So here in this one we will denote this by E1 union E2 by this notation. And of course we can have several sides, so like E1 union E2 union E3. And for here we can also use the Venn diagram to show what this meaning for the union. So here again we have the rectangle as our whole sides, and then we denote it by two sides, E1 and E2, by circle. So the left one is our E1, side E1, and the right is our side E2. Then now the meaning for the E1 union E2 is the area which is covered by one of them. So here I also color this part by our yellow color. So you can see all of this is our E1 union E2. So this is E1 union over E2. So now you can see this union have much more area than E1 intersection E2. So we can say this is our E1 union E2. Okay, so now this is clear what's the meaning for a union. So it contains the elements in either of these two sides. So the third computation is complement. So what's the meaning for complement? So this is very similar to the not in our programming. So here it means it will contains elements which are not or which are not in one site. So here we denote this by EC. So it's a E upper C, or we can denote this by E prime. So this is two ways to show a complement of site, and in different textbooks they will use different symbols, but here I give all the notations for you. There's two EC or E prime. And then again we will use the Venn diagram to talk about the meaning of EC. So again here we will have a site S, which is a whole space, sample space, and then if we denote the one side as E, so here I denote this as a circle again. This is our E. Then the complement of E is a part not in this circle. So here in this case it means all the part outside of our circle. So here I will shadow this part by our yellow color. So this is a meaning for our E complement, or we say this is EC, or we can denote this by E prime. So this means complement of site E. So now we know this is three important computations of sites. First one is intersection, and the second one is union, and the third one is complement. Then similar with computation of some numbers, right? We have like the computation like addition, multiplication, dividing, and subtraction. And here they will have some orders of these computations. So inside, the order of computations of size is similar. In general, we will do this from left to right. But here, if we have a complement, generally we do complement first. But this is, and this we can also use some parentheses to change the order. So here, if we say like E1 union E2, E1 union E2, and intersection E3. So what this means? This means we will do E1 union E2 first, and then by the result of this E1 union E2, we will compute this go first, and then we will use this result to compute this result intersection E3. This is the second part. But here we can also use the parentheses to change the order. So here if we have E1 union parentheses E2 intersection E3, then similar to the computation of numbers, what we will do is we will first compute the part inside the parentheses. So now we should start with E2 intersection E3. And after we get this result, we will continue to compute E1 union this result. So this is our second step. So now you know what the orders of our computations of the size. First, generally we start from left to right, but if we have parentheses, this will change the order. This is exactly same with what we learn in the algebra. And here we also have two more important rules about computation for the size. The first one we call is distribution rule. So what is a distribution rule, or we say distribution laws? This is if we have 3 events, and also we have the order and parentheses here. So this is first parentheses E1 union E2, and then intersection with E3. Then we can distribute this one as E1 intersection E3 parentheses and union E2 intersection E3. So here what we can think about this as a number 1 plus 2 times 3. So generally we will compute the 1 plus 2 in the parentheses first and then times 3. But we can also use the distribution law to compute this as 1 times 3 plus 2 times 3. So here, for sides, this is very similar. We also distributed the intersection to the part inside this parentheses. So that's why in the right-hand side, we have E1 intersection E3 parentheses, and then union the result of E2 intersection E3. So this is our distribution. And similarly, if in the parentheses we have E1 intersection E2 and outside we have the union, then we can also have this distribution. So now we will have E1 union E3 and then intersection E2 union E3. Okay, so this is about our distribution law. And another important rules or laws of our computation of intersection, we call this as a De Morgan law. So it's De Morgan's law. So in this one, what's the meaning of this one? This is not intersection union, but now we have one more computation, the complement. So the rule of this one, if we have parentheses E1 intersection E2 and complement, then now we can compute this as equal E1 complement first union E2 complement. So here this have a very important part. So previous we have intersection inside the parentheses, and after this we have union. So this is very important. It's easy to make mistake here. And then similarly, if in the intersection we have E1 union E2, then after the complement we can rewrite this as E1 complement intersection E2 complement. So again we change the union to intersection. So you can remember this as with in the De Morgan laws, if we have a complement outside the parentheses, then we can distribute the complement inside the parentheses, but we need to change upside down our symbol. So if pre-words is upside down U, then after the complement it will become a U. If pre-words is a U as union, then after this rule it will become upside down U. So it means an intersection. So this is about what's the meaning for the some computational of science and some important laws and rules about these computations. So in my next video, I will give more examples about size, and also we will talk about more relationships between the several sides. So thank you for your see my videos. If you like it, please thumb up it, and please subscribe my channel. So see you in my next video.